until that happens. So, and C++
All right.
doesn't do that. It
Hello,
doesn't let you
y'all. So this is the 7th Godot workshop, and obviously we're covering Godot native, C++, and Rust, mainly just C++, Rust at the end. So before we begin, do you have any questions?
Sorry, no?
Yes.
Am I the only one?
No.
Okay.
I am going to get started by talking about what Godot native is and kind of how it works, and then Duncan is going to go through the lengthy setup process for C++. So, as you probably know, Godot has a ridiculous amount of language bindings. GDScript, C#, C++, C, Rust, D, Nim, Python, JavaScript, Go. Ridiculous amount. More than anyone would ever use in a single project.
Not as many as SDL.
Well, that's C library, but so how it's able to, support all of these bindings when all the other, major game engines support exactly one, is that while Godot is primarily programmed in C++, just like all the other engines, it exposes a C API for all of its language features. So all of its internal constructs are represented in C++, but they're represented in a way that they can also be accessed from C. And so if C is the lowest denominator to actually access all of your functionality, then anything that can interface with C, that is, call C functions, be called by C code, stuff like that, then you can support any number of languages. So the basic, way to use GD native, which is the term for the C level bindings for Godot, is to actually use C. So you can read this on the documentation page. We're not going to go through it because it's lengthy and unnecessarily hard to read, but this is basically what's going on under the hood for all of the language bindings. There's a little bit more going on with GDScript and C# because they're actually integrated into the editor and the engine a little bit more closely than GD native is. But at the lowest level, this is what it's doing. Everything is basically being expressed in C code, and all of the headers that you include are at the bottom C headers, and then they're converted into whatever language. The C++ bindings are additional wrapping around this C level API, and so is the Rust and everything else. Does that make sense?
Yes.
Cool. So with that out of the way, we will transition into C++.
All right. So I will now be showing the extremely long and convoluted and finicky process of installing and compiling and making work the C++ bindings.
Is there shorter ways?
Use Rust.
No, yeah, use Rust.
Okay.
Rust is like 3 steps.
Nice.
Okay, so first thing, I'm just gonna show some of these first steps, but I'm not gonna do them because we've already done them in advance. So the first thing you're gonna wanna do is go to GitHub and search for Godot CPP. Excuse me?
Yeah, GitHub's been having issues.
There we go. Okay, so find this repository, which is going to contain all of the bindings, and you're just going to want to clone that somewhere on your computer, preferably in like I have on my computer a Godot folder in my documents, so I cloned it in there, so it would be easy to get to. And then after you've done that, there's another very important step. You need to open git in that folder,
So it's just whenever I
and
touch the thing,
where's my
it goes
notes?
bad. It's just whenever I touch it,
You need to go into that folder in git so that you're in the repository, and then you need to do git submodule update dash dash init dash dash recursive. If you do not do this, it will not work. Basically, there is a repository inside of this repository, and it is not updated in the outer repository, so you need to run this command to update it.
There's a way to do this when you clone it, but this works as well.
Yeah. So just make sure you do that, otherwise it won't work. So then you're gonna have this repository which has the bindings in it. However,
Just one little note. It's you can use this repository basically globally for any projects that you're using that use Godot. So you don't have to do this every time you set up a project. You just have to do it once for any project that you're doing.
yes. So now we have this repository, but we don't actually have any bindings because we need to compile them manually. I don't know why they don't distribute binaries of it yet, but they don't. Although I think they're planning to at some point. So if you're on Windows, this is substantially more annoying because what you have to do is, we're going to be using scons or scons to do this, which is it's a Python-based build tool that
It's kind of like make.
yeah, it's like make. But for some reason, if you're on Windows, it only works if you run it from the Visual Studio command prompt.
Probably
So
because Visual Studio has a bunch of environment variables that are not set externally.
yeah, so open up the developer command prompt for VS, whichever version you have, and then just cd into that folder and run this command, which we will, can you like write this in the Discord somewhere?
Yeah. I can
So,
do that after.
and then run the command scons, check my notes, scons platform equals Windows, generate underscore bindings equals yes, and target equals debug.
This is also on the all of these steps are on the GD native C++ example on the Godot documentation. So if you need to reference this later, you can look at that.
Yeah. So run this command and it will compile the binaries for the bindings, and then you have to do it a second time with target equals release, so that you have both the debug and the release bindings. And we are not going to do that on this computer because we have already done it, and this computer compiles stuff at the speed of continental drift. So
if you have multiple cores, you can add a dash J number of cores, and it's going to multi-thread your compilation. It's going to go faster.
yeah.
It's actually the number of threads, so like J8 for most quad-core CPUs.
So should we wait for? Have you
Are you
like?
compiling?
I tried to do the scons statement, but whether should I define myself as well?
Do you have scons
So what is the solution?
I don't have it.
Do you have Python installed?
Yeah.
Open up a command prompt. Huh, you don't have Python package manager installed.
What? I also realized our game's not realistic.
Oh.
Do you have Python?
Yes.
Okay.
Kind of though.
Like they should
Open
cast
up
a shadow.
command prompt.
Shadow being.
Where's the flashlight?
Python doesn't work.
Type pip.
Is there a flashlight?
Flash me something on it. Sure. You got a flashlight on here.
Hit enter and see.
Windows is really interesting, isn't it?
I know, I just realized.
There's also
that's
power
that's
but I don't know if that
weird.
It would
I just don't
work just as well, but you
so
use
that's
Python
why
hard copy.
I changed
So,
it.
Oh,
Okay.
there we go. So try pip install
I
scones.
just have.
Because the shadows weren't working.
Okay.
Excellent.
So let's see.
Scones?
We
This,
spent like
uh,
30 minutes.
SCONS.
The CO and this.
Yes.
Scones.
I kind of scaled them up a bit, and he's like,
Okay. It works.
Yeah.
And
Python.
that
he's like, so
should
if I make
do
this
it.
really small, and you can see the shadow.
I can just go to the file.
Yeah, go do that.
Okay, so now we just make
And
the
what
shadow
is-
distance
And then,
very
um,
large, and now you
I
can see
need to,
them.
You need to
clone that.
clone the.
That's the shortcut.
Oh my
Well, yeah, no,
goodness,
so I'm
that
trying to
is
see-
ugly.
So.
Just Google Godot
Yes.
CPP.
I suddenly forgot what Godot is called. Like
Well,
that for
let's
the
hear.
1 second.
Is this?
That one, and then clone that somewhere.
Why, that is a,
Oh, actually, no, I don't want to download it.
this is a shortcut. What does this go? Okay, so, oh, well, that's not much better. Whatever. Let's open a, why this isn't in the path, I have no idea. Where is open with command prompt?
If you type, are you just trying to open one in
Yeah,
this
no,
folder?
our thing was,
Yes.
hey,
CM
it doesn't work on
into
here,
the
does it
search
work on
bar.
another scene? It works on another
Okay,
scene.
yeah, that is ridiculous.
Just not yours.
Okay,
Encased
so,
below, if you like, up level,
Python.
so you can't see the scenes.
.exe,
Does that work?
and there.
And then what do I do?
It's
Add
called
really fancy
scones.
with a flashlight that doesn't really
Oh,
work.
Okay, so then,
Should be like
go
Go to
open
the, go to the,
Successfully
the.
solved. So you have scones.
and then
Is it this?
you
No.
get dash.
Okay, so,
No, it's the, cause on the other scenes, like,
Just
they're
type
closed,
D
but you can tell they're closed, but when
without
on his and you zoom in,
edges
you can see there's like
on
this,
do something
like tiny cracks.
like through the editor, is that
I think they're like, yeah.
And do you have a good dash?
Like this way,
I think I do.
Oh.
like, if they're
did
just
that copy?
somehow like.
So open git bash in that folder with
Like it was tiny cracks.
Insert. Yes, it is that, and that,
make it
and
longer
that.
in per second.
That is
That
like,
one.
okay.
So you can't, you can't do that.
Scale of everything water to the sea by 1%.
Path.
Oh, you have to do it,
And then
You can do
Then-
it through.
So
you can do
open
mine
that
if you wanna
folder
copy
in
it.
Git
I
dash.
think if you do it through
Wait,
there, it
is it
scales it,
a
so you can
semicolon?
mark on it, the art will
Yeah.
scale.
Feeling it's semicolon.
And it looks stretched and gross.
Python.
Oh, actually, I have to open it
Okay.
here.
Yeah.
Sorry.
So CD into your, Godot, native Python. Yeah. It's gonna be really interesting.
Try copy pasting.
It's okay, at least you made the.
That's fine.
Yeah.
Those work.
Paste that whole directory.
Yes. So now we just need to, no, scones, and then it was,
Just go into D.
Oh,
project.
for some reason, technology doesn't.
I have another
CD.
oh, right.
Just like,
It's called platform equals Windows.
Okay, then
It was debug and then target equals something else. Okay. Where are those?
Target equals debug, and then target equals release after that.
Okay, now do git submodule
Why did not add it to the path?
dash dash init
Python.exe.
dash dash recursive.
This is ridiculous. We're just gonna do
That's
this
it?
then.
Yeah. Okay, that worked.
Yes.
Hopefully. So now you have Visual Studio, right?
Yep, I do.
So search for
I found out
develop.
the shadows.
No,
don't,
in
like,
your search.
The flashlight doesn't
Developer,
have the,
yeah, open
the
that.
cache shadows, but when we cache shadows.
Now go back to the
Yes,
main folder.
This is ridiculous.
Because our camera was like going.
What is happening?
So Scon's
so
is a package,
shadows are
it
like
can't
slowly
be
waiting,
directly
and then
executed.
it starts going,
Why?
it's like it's waving around, and then it's like, maybe it's good,
Well.
we don't have the shadow.
Is it in site packages?
Is the flashlight for the follow? That's how it works.
Flashlight takes a little bit of time to catch up with the player.
Yeah, so it's
I mean, so it's not just rotation, it's also translation.
Yeah, I mean,
Yeah.
we can continue to do this.
Now
but-
run.
yeah, so if you look at
Type
shadows,
dirt,
they
just
like
make sure.
take they take
dirt
that extra time, and you can
DIR.
notice the shadows are like wait.
Would that look weird? That would.
Oh,
It does look
so
weird
now
if you
type
fix it.
sconce platform equals Windows.
Is shadows that big of a deal?
No.
Generate
Yeah, we don't
underscore
need it.
bindings
If anyone ever knows, there's no shadows in the game. Wow, because when we had
equals
shadows.
yes
And then all of this.
Target
crap. Where is this?
equals debug.
Why is this door so off?
That should be it.
I hope my computer is not
This is Mac.
create, or it is.
Oh, it's
Well,
working.
Yes.
if you can install Python and add it
Oh my
to your
God,
path,
your
I would do that.
computer is so
But for
much
now, we're
faster
probably
than
gonna
that one.
Really?
move on.
Yes.
Alright. And also,
I
yeah.
think
the,
I will
docs
pass
have
the
all
word
of
off to
these,
I know why there's so many
instructions.
scenes.
Okay, I get it.
Jack, you're still using a very
I
old
think
free
we're
tab of
gonna
level one.
move on,
Yes,
but
we are.
hers is actually compiling, so
Nice.
that's good.
On the production level?
Windows
And
is
I
an
don't
enemy.
think you need to compile both. You can just compile the debug one for now.
And then you can
Change
compile
our
these.
the entire thing to release.
Yeah. Okay, so now what we're gonna do is we're gonna make a new folder for our project because we have to give it a very specific structure. So we're gonna open this, we're gonna make a source folder, and the other one can be whatever you want. I'm just gonna call it game. Now we're gonna open up Visual Studio, and we're gonna make a new project, empty project, in our source folder. You can call it whatever you want. So it's gonna make that. Okay, so now we need to do a ton of really tedious preliminary setup. So let's switch this to x64, and now we need to change some project settings.
Oh no!
Yeah, it's not fun. So, so we are going to change configuration type to DLL, output directory to, oh, I should make the Godot project first.
Wait, let me make the first.
Okay, so,
So this is called empty project, right?
yeah, and make it in the game folder, in that new folder.
In that what folder?
The, when I showed making a new folder, put it in, with like a source and a game folder, put it in the game folder.
I'm confused. What?
So I made a new folder for our project, and in there I put these two folders,
Okay.
source and game. So
So
put,
after I make the project, I make the folders inside the projects, right?
no, make the folder first,
Okay.
and then when you create the project, tell it to put it in the game folder.
Why is there a laser in the word? Because we want to.
Okay, now we can go back to Visual Studio, and
And put in the source folder.
no.
Put in the game folder.
The Godot project goes in the game folder, the Visual Studio project goes in the source folder.
Yes, that's what I want. I interpreted. Okay.
So our output directory is going to be, oops, is going to be in our game folder, inside another folder, which we can just call bin.
Oh, this is great.
It definitely will.
And then I think that's everything we need in this section. Then we need to go to our directories, and for our include directories, we need 4 different ones, which are going to be in the Godot CPP folder. And those are Godot headers, no, come on, include, gen, and include core. Then for library directories, we're gonna pick the bin folder. And then the last thing, under linker input, additional dependencies, we need to type in this ridiculous thing that I have in my notes, which is libgodot $cpp.windows $$ platform $$ configuration.lib. And basically what that's doing is it's auto-detecting the platform and configuration we have set, and it's just finding the file based on that. Oh yeah, one other thing. When you initially compile the bindings with scons, it names them the wrong thing. So you need to rename them to these names. I don't know what they are initially, but
What they are now.
it's libgodot-cpp.windows.x64. Either debug or release, depending on which one you have, .lib.
Truth be told, I'm still compiling, so.
Yeah, so we can come back and like help you with any stuff you need help with
Okay.
when that's done.
Just watch me.
And I think that's all the settings we need to do. So now let's actually start writing some code. How about it? So let's add a new item. And this is C++, so of course we need a header and a source file for all of our classes, I think. But even if you don't, it's probably best to do it that way. So we're just going to make player.h. And there's a very specific format that you need to follow for these files, which I will try to explain as best I can. So first thing we want to do is, because this is C++, we need to include all the relevant files. So we always need to include godot.hpp, and then we're also going to need to include, like, for example, the class that we want our player to derive from. So I'm going to include kinematic body 2D, so we can make our player move. Alright, so after we do that, first thing we need to do, this is all going to be in the Godot namespace, because this is basically where it checks for any classes you've added, and it finds them in there. So we're gonna put all this stuff in namespace Godot, and we're gonna make our class, which I'm just gonna call player, and I'm gonna derive from kinematic body 2D. So as far as the format of this class goes, the first thing you need to do is use a macro called Godot class, which takes the name of your class and what you're deriving from. And if you mouse over this, you can see it just does a ton of crazy stuff that sets this up so it'll work with the bindings. And
in the back end, it's actually a hash map between strings in a class. So yeah,
yeah.
it has to set all that up for you.
All right, so now we're gonna.
As a good news, we have the micro.
Yeah.
Yeah, that's basically all of the bindings.
Yeah.
Good news, we have a macro.
So now we're actually going to put some members in this class, and you can lay this out however you want. I'm just going to do the way I normally do it, which is I'm going to put my private member variables at the top. So these are just some things that I'm going to use to make the player move, but I'm also going to have...
Can you increase the font size?
That's not the button.
Probably. No, it's not that easy. It's Visual Studio. What are
No,
expecting?
yeah, why would it be that easy? Options. Fonts and colors.
Oh,
What a functional program this is.
I know, right?
There you go.
That's better.
Much better.
Okay, so I'm also gonna put an int in here just called myInt, because I'm gonna demonstrate how exporting stuff to the editor works in C++, because it's a bit more complicated. So now that we have those private member variables, I'll also, if we have time, I'll show you how to get a reference to a child node as well, if you want to do that.
I'll be covering getting references in Rust as well. It's
Okay.
basically the same process.
So, because this is a C++ class, we need some stuff that we wouldn't need in the other languages, like a constructor and a destructor. And now we're getting into the stuff that you absolutely must have in your class or it will not work. So first off, there is a static method called _register methods. And this basically takes all of the functions and properties in your class and helps, it registers them with the reflection API so that they are visible in the Godot editor.
It's also so that it knows what to call. Again,
Yeah.
it's a hash map with string to a function pointer. So, yeah.
So this handles all that. And then, very important, this is not something you have to put in either GDScript or C#, but you must put it in C++. It is the init method. If you do not put this in your class, it will instantly seg fault when you try to run the game. You don't have to put anything in here, you just have to make sure this is declared and defined, or it won't work. So that is all the stuff that you absolutely need, and then you can just put the stuff you want to have, like the ready method and the physics process method, for example. That's not right. Float delta. And like, if you wanted to put some private functions down here, you could do that too, but we're not going to do that right now. And I think that's everything for the header file.
For the register message, we're gonna write the message, or is it also like in it, we don't need to put anything in it?
We're going to write the methods. So let's now make the source file. player.cpp,
Gravity's always pointing down.
include our player.h. And now we are no longer in the Godot namespace, so to make things easier, we're just going to do using namespace Godot, so we don't have
the
to.
same namespace thing, but
Yeah, you could. I don't.
You can't use any of that.
Yeah, you could do either one. So now we need to define all of our functions, and usually I start by defining the register methods.
Yeah, we'll pick more basically just stuff.
So in here, what you need to do is for every function that you want to use, you have to say register method, then give it the name of the method as a string, and then a pointer to the actual method.
The tutorial's in there.
So we're going to do that for both of the ones. Oh, you don't need to do it for init, you just need to do it for everything else. So we did ready and physics process.
So the arrow indicates that your gravity.
as a general interest thing, if you were wondering how internally Godot runs ready and physics process in all of its languages, it literally just looks for the _ready and _physics process methods defined in this way. So, you know, it literally has the string ready and then pointing to the actual function pointer, and that's how it's done in every
So many times you break.
language binding.
I see.
Alright, so that's done. Now we just need to define our constructor and destructor, which don't need to do anything. We also need to define...
You have to have a destructor then? Or
I don't know. I've just always put one because it's in the sample that they give.
Yeah. It's fair.
You could try not using one, but also you have to define init or it'll crash, but we don't need anything in init. Now we can actually define ready, and in here I'm just going to demonstrate that this works by printing something. And the way to print something in C++ is there's a class just called Godot, which has a static method called print. So I'm just going to say hello there. And then I'm going to define physics process. And real quick, I'm just going to do the code that allows for movement. So here's another difference. In C++, you can't just access the input singleton directly like you can in the other two languages. You have to get a reference to the singleton. So the way you do that is by typing input. Oh, first you have to include input .hpp, and we're shut up. Input get singleton, and this will return a pointer to the input singleton, which you can assign to a variable and use that for your input checking. So real quick, I'm just gonna set this up. I can just copy paste this. And then we have our vector 2. And other than some of this weird stuff, it's mostly just the same functions as in GD script and C#, except it's C++. And they're all snake case, just like in GD script. So then we're just going to move and slide velocity times some random speed. Probably make a variable for that. And I think that is everything we need in our source file. So we now have a header and source file for our player class. We're not done yet. We need one more general source file that you need to have in every project, which I'm just going to call library.cpp. And this file is going to run all of the initialization functions that basically set everything up for the C++ bindings. And it is literally just a very specific thing you have to type, and I do not have it memorized, so I'm just going to copy paste it from the GD native C++ example page.
So we have to do this for every single project?
Yes.
Well, every library that you have in your project. So you can have multiple C++ libraries,
What
and
is
then
the use of that?
I don't know why you would have that, but if you do have different libraries, then you do have to do this on library basis. Maybe you have a library that you downloaded or you're using externally, and then you have your own library for your own functions. Is why you might have two different libraries.
Okay, so in this file, what we need to do is we need to include all of the classes we've made. And then at the bottom here, where it says register class, we need to put one of these for each of the classes we've made, but we only have one. So, hello? Why is that? No, there we go. So we need to put one of these for every class that we've made, but we only have one, so we only need to put one. And I think we are good to go. So let's try compiling this and see what happens.
See if
It didn't fail.
Yay, first try. So now if we look in our project folder, in the bin folder, that's interesting. Why did it make all of these things? Well, we have the DLL, that's what's important. So now, let me just make a scene real quick and put a kinematic body in it, which we will call player, and I'll give it a sprite. Move that over here. So now we actually need to make two things. In addition to the actual script that we're going to put on our player, we need to create a library file that will take that DLL and actually use it. So in our bin folder, we're going to make a new resource, which is a GD native library. We're just going to call it game.tres. And that's going to open up this view here. And this is basically where you put all of the compiled library files for all of the platforms that you want to export to. So if you were doing this for an actual game, you would want to compile those files for Windows, Mac, and Linux, which is probably a huge pain depending on
In
the
C++,
platform you're on.
it sure is. If you're on Windows.
Yeah. So we're just going to, all we've done is compile them for Windows, so we're just going to put them in there. So come down to Windows 64 and select our DLL file. And there's some properties over here that you probably don't need to mess with, but if you ever have, sometimes it doesn't automatically reload stuff. If that happens, try like unchecking this and rechecking it. That might fix it. I'm not sure. So now we have our library file. Now we need an actual script. So we're going to attach a script to our player. And the language is going to be native script. And for class name, you have to put the exact name of the class in your library that you want to give to this script. So we're going to say player.
If you think about it, this is what it knows which class to do because you gave it, that hash map of strings to classes. So this is you basically saying what you told Godot the name of your class was.
Yeah, so create that. And then, very important, come over here and where it says library, select our library that we just compiled. And if that entire process worked correctly, we should be able to move now. I think I got the keys backwards, but it doesn't matter, it works.
Hooray!
So, let me check that. Did I accidentally... Yep, got them backwards. This should be up, down, right, left.
Right on Y.
That's a good point. I am really tired. I'm sorry. Okay, be sure to recompile it every time. There we go. Now it works properly. Yay! So now, real quick, let's go over some of the more miscellaneous things you can do, like exporting something. So let's say I want to make this int visible in the editor. So the way we do that is under our register methods function, there's another function called register property. And this is a function template which takes the name of your class, or the type of your class, and the type of the variable you want to export. And then you need to give it the name. This does not have to be the same as the actual variable. This is the display name that is going to show up in the editor. So I can just say like...
None of the names you give it actually need to be the same, but typically you want it to be the same.
Yeah. So like if I say sum int, that'll still work. Then we pass it a pointer to the variable.
You might not want to put spaces because this is how you access properties in like GD.
Oh yeah, so let's not do that. Let's just make it the same thing. If you make it the same thing, it'll do the same thing where it automatically capitalizes it and adds spaces. So put that, my int, then what's the next parameter? Default value, so let's just say 0. And that is all of the, that's all the parameters that are required. There are some optional ones that are really annoying to work with because they use these ridiculously long enum values, but of course not either of these, but this one is if you want to give it a property hint, like tell it that this variable should be within a certain range, or this is like a color. Actually, no, I think that works normally.
If it's like an enum value.
Yeah, if it's like an enum, but we're not going to do that right now. So, oops. So if we just put that, this should hopefully automatically reload. Damn. Why isn't it? If I close this. Sometimes you might have to restart the entire editor for the. Where is? I thought I named it something else. I guess not. Wait. Yeah, this is a different project. Oh dear. What has...
Just import it.
No, there's no player object. The entire team is broken.
There we go. It showed up. So that's how you export stuff. Why is it not?
If you're interested, the way that it actually achieves this is a setter and getter function. That function template register property creates local setter and getters that don't actually need to interface with your class because it does pointer magic. But internally, yeah, it is a setter and getter function that similarly is just passed as a function pointer. Yeah. And the reason it does that is because, you know, it's a C APA, classes don't exist in C, so on.
I'm trying one more. Let's see if this actually updates. Nope. I don't know why that's not working.
Anyway,
Am I forgetting anything else I
we
should
are kind of
explain?
strapped on time.
Yeah, so there's like doing certain things is substantially more complicated in C++ than in any of the other languages, like some of the stuff involving singletons. But if you ever have questions about how to get that working, just let me know and I will help you with that. But that is the basics of getting C++ working. Any questions after that ridiculously long process?
So, I'm going to do Rust. I don't have time to do. I don't have time to do everything that I wanted, but
Wait,
it's fine.
hello there?
I have no idea.
Yes,
Hello there.
Hello.
So, I was going to ridicule C++ by setting up a new project, but I don't have time. It takes like substantially fewer steps to set up Rust, but I have a project already done. So I'm just going to open Godot,
We're prepared.
and I'm going to import Godot Workshop 7. So how I have this set up is in Documents, Godot Workshop 7 Rust. So this, ls is not a valid command. This is my, very similar to how C++ was set up. This is my Rust repository. So this is the project directory for Rust. It's actually created through Cargo, so I can just do this really quickly. Is there a make directory?
Yes.
Okay, Dir?
Yeah.
Yes.
Okay.
Should
Well, actually, no, I can just do this. So how you would set up a Cargo repository, Cargo is the package manager for Rust. So you would just do cargo new lib my Rust project. So then we go into my Rust project, and it sets up the entire repository for you, and you don't have to do anything. And so if we go in, so let's actually, whatever. So if we open up code, No, that was my old one. So if you're using Visual Studio Code, there is a
Oh, yeah, cool. I love code.
yeah, there's a Rust plugin, and so yeah, so this is the project that I have already done, and so the way to the only thing that you have to do to set up a Rust GD native project is you need the GD native dependency. You should have it be the Git link rather than any sort of project version. Obviously, I don't think either of you know Rust, but this is how you specify dependencies. And then your library needs to be crate type C dynamic library, cdylib. So that is literally all the setup that you need. So let's go in here, go into Godot. So also, yeah, I have this set up similar to how the C++ was. So we have the overall repository, and then we have a Godot project inside of it. The reason you don't have the Godot project at the root is because it's going to import any files that your build creates, and you don't necessarily want that. So I'm just going to import this project, import and edit. So the project is already set up, but I don't have any anything built yet because I just cloned this from my repository. So to build it, I just type cargo build, and it's done. Oh no, this is the wrong one. Let's go into workshop 7. Now, workshop. Why is it? Oh, Godot workshop 7. Godot workshop 7 Rust. Cargo build.
It snaps your surface normal. But that's actually a direction.
And it's just gonna build.
Rotating rock you're standing on it, it would just kind of dump you off.
That is fast. That is fast.
It is. It's actually probably slower than compiling C.
No, I mean like the process.
Oh, the process is ridiculously quick. That's literally all you need to set up for Rust, is that folder that I showed, and then you get to this step. So while that's compiling, I can show you the actual code. So this is similar to the file that Duncan created that was called library.cpp. So this basically just specifies the library that Rust creates. So we do similar things. This is just like including the Godot header. And so we have an init function very similar to C++. And here we're adding our classes. This is basically just different syntax for registering classes in C++. And I have 2 classes. I have a singleton and a node 2D. And then we have some other boilerplate code that we don't need to worry about. Just know that under the hood, this is doing the exact same thing that the C++ bindings are doing. So this is continuing to build, as is this. That's going to take a while. So my node 2D. So this is how you specify classes. Rust doesn't have classes, actually. So actually using something that is completely structured around classes with a language that doesn't have classes at all is very interesting. But the actual thing that we do is, pretty interesting, and it gives some insight on what is happening under the hood. So we have a structure. It's just a plain C-styled struct, and it's called myNode2D. It has 2 members. There we go. Speed, 64-bit floating point value, and a node path, which is a Godot thing. I'm actually including that node path in here with use gdnative star. So this can also be gdnative ... node path. And so that's just located in the gdnative library.
Would you be able to make the font a little bit larger?
Yes. Let's see.
Control plus.
This is why I
there.
love code.
So, that's literally all of the data that my class is holding. And you might be wondering, how on earth are you implementing a Node 2D with that little data? And the way that it actually functions, and this is the way that it functions in C as well, is that your methods take your owner, that is to say your whatever you're deriving from, as a parameter. So you're getting all of the data that you need to manipulate. It's just a separate entity. So this is, the struct, and then we implement a trait called native class. And you tell it what you want to quote unquote derive from. I'm deriving from Node 2D. Let's see if this is done building. That it is.
It is.
And so I'm deriving from Node 2D. So with that knowledge, let's hop back into Godot and set this up really quick. It is essentially the exact same thing that you're doing. So you have your rust test.gd and lib. That's just your library. So on Windows, we're choosing the 64-bit. We're going to go up a directory, target, debug. Oh, come on. Up a directory. Why is that not working?
Does it even let you go out?
Oh, it definitely, absolutely might not. So let's just, oh, I didn't think about that. Windows is weird. I don't use Windows. You didn't know. So let's do this. So this is going to be weird, but I'm just going to do it anyway. There's better ways to do this. Oh, come on. Target, debug, workshop 7.dll. I'm going to copy it. That's a really bad idea. And I'm going to put it in bin. So our library is in bin, workshop 7.dll. Basically the same thing. You might want to not do that. If you're making your own project on Linux, that works fine. On Windows, apparently it doesn't. So yeah, so we just have our DLL. That was built by our cargo build command. That's essentially saying make in C++. So now we have that. And I already have some scenes set up. So this is my test scene. This is almost identical to Duncan's. It might not have the speed set up. So let's do the thing that Duncan also did, and that is restart. Where did it go? Where did it go?
Workshop 7?
Workshop 7?
Oh, where is it? Oh, there it is. Yes, okay. So, opening up that scene one more time. Oh, come on. All right, test scene. Come on, open it. Thank you. So, we have a speed. Set this to 100. One was a terrible value. And a singleton path. We'll get to that a little bit later. So yeah, this is basically identical to Duncan's thing.
Yes.
So going back to the code that makes that possible, so this native class, this basically just implements a bunch of functions. This impl block, this basically just adds quote-unquote associated methods to your structs. It doesn't have anything like C++'s inheritance, multi-inheritance, polymorphism, or anything like that. It is literally just associated methods and types. So our base is Node 2D. That doesn't add any data. Our user data, this is complicated, and I don't have time to explain it. So some required methods are class name. My class name is myNode2D. That can be whatever you want. That's just how you access it. In Godot, that's right here. So I put that in class name right here. That's attached to my Node2D. So that's just, that relationship. Init, this is similar to C++. You just have to have an init function. It doesn't do anything. My init function, I don't even know if I have one. Oh, I do. So this just constructs my struct. So unlike C++, Rust doesn't have constructors. You just have methods that construct a object for you. They're more explicit. So this just sets the default values, default value of 0 for speed, default value of a node path from -root -my singleton, you know, just basic construction. So we have a very similar register properties method that, you know, adds your properties, similar to in register methods or whatever in C++. So I have a speed property and a singleton path property. Unlike C++, you have to manually specify the setter and getter functions. These are called closures. They're lambdas, and they're basically just saying set this dot speed or give this dot speed or whatever. And so here are the actual methods. So this is just a raw impl block. This is just basically where you have associated methods for your class without any trait that you're implementing. We have a tag. This does some boilerplate stuff to register the methods for you. Otherwise, you just have an export tag. So, you know, at this point, it is literally you're just writing GD script in Rust. You have your process and your ready. They take a self and your owner. You know, for my ready function, as we can see if we run the game, it will print from node 2D high and high Rust only. That is achieved in this _ready function, where you know, we find the singleton node. I have a singleton set up for the project. It's in root my singleton. That's how it accesses it. And coincidentally, it is also written in Rust. So this is all the Rust stuff. I don't have time to go over it, but yeah. So we basically find the node. You have to access the owner to do any methods that are associated with GDScript nodes, such like, you know, get node or translate. You have to access that with your owner rather than yourself, because that data isn't actually associated with your object. So we get node. This is just like saying get node. We give it our singleton path with some fancy syntax, and then this unwrap. So if you're unfamiliar with Rust, this unwrap means there's a possibility this value could be none, or throw an error. So you have to explicitly say, I am okay with this throwing an error. Otherwise, you can actually do this in a you know, match block, match something, some like return value, and you would say, if it's okay, okay, then you do something. If it is error, E, then you would most of the time print line the error. But, you know, that's just Rust. So yeah, we are explicitly saying, I'm okay with this throwing an error if this is none, otherwise give me the singleton node. Then we get a singleton reference, which is very fun. So due to some Rust shenanigans, it doesn't like things that are unsafe. So you have to attempt to get a reference to the singleton from its parent. This is us saying we want an instance of this Rust struct called mySingleton, which I wrote up here. No, it's just this. It's just text. So attempt to interpret this node as mySingleton. Then we, from that reference, we call some methods on it. Again, this is a lot of Rust boilerplate. This is typical of Rust where, again, this could throw an error because it could be freed, so we need to do some stuff around it to make sure our program doesn't crash. And then at the end of the day, it is able to actually run singleton.print text that is defined right here. It's right here, print text. and then also singleton.printTextWidth. That is defined right here. So yeah, I mean, I should probably do this because I don't want to change anything. Whatever. Anyway, yeah, it ends up being, we should also probably look at the process. Very similar to what Duncan did. We get the Godot singleton for input. We construct a vector2, and then translate based on that vector2 by speed and delta. For some reason, this is passed to 64-bit float. I have no idea why. But it works, and it's cool. Our workshop is basically 2 minutes over, so do you have any questions on that? I didn't write anything up on how to do this for Rust, but if you're interested, I will absolutely help you one-on-one.
As will I, if you want to do C++.
Yay!
Yay.
I have no question for now, because it's a lot to take in.
Yeah, it is a lot to take in, and it's a lot less convenient working with Rust. You can use, so what most things do is they actually use a combination of GDScript and C++ or Rust or some other faster language, because GDScript is pretty slow, so you can't do a lot of like computationally intensive tasks, stuff like A-star pathfinding. That's something you would probably want to implement in a C++ library. Or if you want to interface with a different C++ library, you do that. But how you do basically all of your other code that isn't quite performance intensive, you would write it in GDScript. And as I'm demonstrating here, you can just access Rust or C++ methods in GDScript. So we have my singleton. This is, you know, just defined here, and we have a thing called print text, and from GDScript we can just call .print text. That would have auto-completed if things were better, but it should auto-complete, and you can just call it directly. And if we call this, it will say, oh, that's the wrong one. If we run the use my singleton, then this code will run, print text, and it prints hi. Yeah. So that is that. I will stop the stream.